kind of within an individual, right, over time. And this is in contrast to, say, cross-sectional study, which is taking a snapshot of a few individuals, or they may try and look at trends by doing a snapshot repeatedly, but with different individuals, say like of, you know, third graders every year or something like that. And so that's different, even though it creates a line and a trend line. But we are looking at longitudinal data because we want to see changes in the newborn relative to or related to newborn screening to a specific intervention. So just to clarify that, and then next slide, please. So then what in particular can longitudinal data tell us? Because this is data that we get over time with repeated measures. So the main things particularly relevant for newborn screening is natural history studies, or so-called natural history studies. That is where we can follow development, right? It helps us understand the progression of development across a period of time. Ideally, a longer period of time, although that takes a lot of resources to continue to collect data and track and everything, but at least for a period of time. And it's usually relevant for a certain set of exposures, or for instance, a natural course of progression of a specific disease. And the other main purpose and importance of longitudinal data deals with looking at treatment or intervention effects over the long term. And here's where we use repeated measures to assess change, so from pre to post intervention. And it's usually actually more than just pre to post to be considered long term, although there's no set definition. It's usually, you know, more than just right after the intervention. It's usually after, say, like 6 months or a year or something like that, to see whether those changes are starting to are lasting. Next slide, please. So yeah, thanks. So now longitudinal data in newborns and children. There's a few other important considerations. As I'm a child and school psychologist by training, so I have to kind of make sure that we are all clear about these pieces because assessing children, newborns and children, is a little bit different. So we still, for longitudinal data, we still want to look at repeated measures, or use repeated measures to track change in outcomes or the target variable of interest over time. But the important thing is that we also have to account for typical developmental changes that are occurring as a natural course of infancy and childhood. So typically that period in infancy and childhood is when some of the most accelerated or rapid changes occur in development, right? They're growing and developing brains, motor function, et cetera, in typical development. So there's an amount of change that we expect to see over time. So the baseline, if you will, is different. A disease or treatments may alter that rate of change. So it's also then important to make sure that we have an appropriate comparator to assess changes, because it's not just the time factor. So just some things to note. Some assessment tools will vary in how they measure things and how they account for that developmental aspect. I've thrown up a couple examples. So for instance, motor milestone measures. I think there's a CHOP and 10 score and a Hines measure that look at, for instance, motor milestone development, where they are essentially, you know, the score accumulates as each milestone is achieved or observed. And so the higher the scores, usually related to age, right? And at some point, most kids will start to ceiling, at least in typical development. There are other measures, for instance, standardized cognitive measures, or what we kind of know as IQ measures, that have a lot of that developmental growth and change built in. And that is, you know, they'll take a raw score, so you still may be asked and get a raw score of number of questions answered correctly, for instance, and that would be the raw score. But IQ scores will convert those so that they use standardized scores, so that, for instance, an IQ score of 100 is set to be the average, suggests average cognitive development across all ages, and that's actually from birth to adulthood. And that's just the way the tests are used for a different purpose. And so one of the reasons why that's important is that in trying to assess longitudinal changes or in intervention effects, the measure will need to be sensitive to change. So you probably have gathered cognitive IQ scores are typically not in and of themselves, with the standardized scores they're not intended to be sensitive to change, because they're actually converted so that they account for a lot of other things. So just something to keep in mind. It can get more tricky. That's when I would, you know, phone a friend and just do a quick consult with a child psychologist of some sort, or someone who's familiar with the measures. But something to be aware of, because those are some pretty commonly used long-term measures in relative to newborn screening. So next slide, please. Okay, so now let me go to longitudinal data for newborn screening, and in particular as is needed for a RUSP nomination. So I think you all are learning, like, there's multiple processes for a RUSP nomination. There's multiple gates, multiple reviews. Just very briefly, I think it's worth highlighting, as you'll see, but there's first the nomination package itself, and it has some key questions that are considered. There's the external evidence review, if the committee votes to move that forward and request a full evidence review, which is where I and with Alex and the evidence review group come in and do our work. And then the committee reviews all of that full evidence review and uses a decision matrix to guide their decision-making process. There's a lot more evidence that comes out and is considered, but you know, there's at least some guiding criteria. So again, very briefly, because I know this information is being covered by others, but next slide, please. At the first gate, if you will, for the nomination package, right, there are the 6 questions that the nomination and prioritization work group, that subgroup kind of off the committee, that's reviewing the package will look at whether the condition's medically serious, is the case definition clear, screening analytically valid, is the screening process clinically useful, that is, does it identify kids who they can treat, are there established and approved treatment protocols that are available and well defined and, you know, prescribed for, you know, for ages and conditions. And the latest one, are there prospective pilot data? And there are other specific criteria about that I believe are being covered elsewhere. So in this one, as you can see, there's actually no specific requirements for longitudinal data required in the nomination package. But alas, it is still very important. Next slide, please. So then at the next gate, the systematic evidence review, and now I'm not going to go into the whole the whole machinery of that. But the overarching question that's really being asked is, does newborn screening lead to better health outcomes compared to usual case detection? That is compared to the standard of care, which is usually newborn screening versus clinical onset. So there's nothing specific in there about long-term follow-up, but again, it's related, it will be related to the better health outcomes. That's probably the best thing, right? Is that going to be, sometimes it's going to be more important to gauge them longer term. But again, nothing specific about longitudinal data. Next slide, please. And then the last gate, right, from the full evidence review of the criteria that are going on, the committee will, in the end, be reviewing this decision matrix or using that as their guide. And they are looking at the evidence overall and looking at the apparent magnitude of net benefit. Like that is the strength of the benefit, right? Is it seems significant, moderate, weak? The certainty of the evidence. Is this based on all gray literature, abstract conference data that's not been peer reviewed, or that has not used validated measures, for instance? Those two are the biggest criteria, and then readiness and feasibility of the newborn screening programs to implement the screening and expand the screening, because it's a big undertaking. So those are the main considerations. So next slide, please. So as you can see, in looking at all those gates, there are actually no specific requirements for longitudinal data at any stage in any of those gates. But it's still very important. And so part of the reasoning for going through all that is that, you know, you really need to look at the whole and what this whole of it, all of the whole set of questions that are being asked, because it's going to take looking at, there may be strengths in one part that help offset other areas, because it's nearly impossible, or at least I've not seen any condition or evidence that hit every single criteria, like unquestionably. So as probably most realize, it's not an easy, this is not for the faint of heart, to put together a nomination package, and it takes a team for sure. But nonetheless, what I wanted to also at least share, again, just from my own experiences, not from, you know, keep in mind my disclaimer, my observations of what I see about follow-up data and kind of and how it relates to reviews that have gone through. First of all, I'm going to actually skip down to that third bullet in terms of follow-up period, because that's the main thing for longitudinal data, right? How long out are you looking? There has been clearly no required minimum requirement for follow-up data periods for the length of follow-up. Of conditions that have been reviewed, they have ranged. I will say that what I've observed is that given that there seems to be great consideration of the context of evidence on a larger scale. So for instance, the briefest follow-up period that I guess that we worked on a review has been about a year, which is pretty tough when you're looking at motor milestones, right, where things can still change. I don't have time to go into it, but there are questions of whether, you know, there were some, where the trajectory was going, and also why it's important to continue doing the follow-up data. But there were other things about the overall collection, if you will, or the body of research that was established. including actual direct tests, if you will, direct studies testing the effects of treatment on pre-symptomatically identified newborns, and which is actually I think the first review that I was a part of that had a direct test of that question. There were also I'll hit some of the other things, some very good and strong, clear case definitions of the particular condition, as well as the phenotypes and the severity continuum of which particular patients they were looking at, and distinguishing the different outcomes. The data elements, the target outcomes, if you will, being measured were very clearly defined. And in particular for the measures, and thinking about longitudinal data, they were validated for that target population. That is, there were adjustments made for the developmental achievements that were demonstrated for this kind of different natural history, natural course for that particular condition, which made it much easier to understand whether change occurred and for how long and across which periods. These measures were also used consistently across different studies and different trials, and there was a lot of validation data. So those were some other factors that, while the follow-up period was shorter, seemed to, again, my opinion only, but seemed to help kind of create a balance overall. Yeah. And yeah, I just listed also some of the specific measures. For instance, the CHOP and TEND, some motor function measures of the CHOP and TEND and the Hines were developed and validated specifically for use with that population, and were used in multiple studies, which help strengthen other pieces, I think, of the evidence base. So again, while there are no specific requirements in the review process, questions and criteria, longitudinal data is very important. I'm hoping that some of these observations can kind of help provide some guidance and insight as to how to think about it and preparing a nomination process or package. And next slide, please, just to wrap up. Thank you. And just a reminder that that newborn screening, collecting longitudinal data doesn't just end with a nomination. It will continue. The importance of it continues and perhaps gets more important, I don't know, for when it's added, when a condition is added to the RUSP. Newborn screening is a full system and process that continues. And I've just highlighted a few of the resources out there that that other stakeholders have put together that have really worked to address some of the different challenges that occur in long-term follow-up. I won't go into that because that's probably at least a few other talks, but there are registries, there are many more registries, there are registry guidance through NIH, there are shared platforms that address the different privacy and there, the MVSTRN yeah, and the ongoing work groups and technical assistance groups that they all have. Those are other resources to help think about not only the how to do this, what measures important, bringing together more patients and information, but also helping clarify and make clear some case definitions and guidance, as well as the ongoing management. As you know, with newborn screening, once it starts, it does start to change the landscape and the natural course of disease progression. So Next slide, last slide, please. I just wanted to end with, this was in one of our efforts and activities for the committee. We were looking into long-term follow-up for newborn screening overall. And I think it's relevant here because, again, the importance of longitudinal data in newborn screening, and some of the other experts in the field through different interviews and whatnot were very adamant, if you will, about these points, that evidence about long-term effectiveness of newborn screening is generally lacking, but very much needed for both survival and other important health outcomes. There's newer conditions coming on, the comparator and natural history data to be able to understand if there are positive benefits. That can be very challenging to find the most appropriate comparison population, and to look at that change over time, and also for families, clinicians, and other stakeholders just to understand what lies ahead, what comes next in watching the effects of both screening and early initiation of treatment. Long-term outcomes will change over time. We can expect that. There's ongoing advances in screening technologies, healthcare interventions, and new treatments coming down the pipeline at a pretty fast pace, and that all is, again, changing the natural course of living with a condition. And so please do continue with the longitudinal data collection. That is the end.
Dr. Lamb, thank you so much for a wonderful presentation. In the interest of time, I think I'm just going to limit it to one question. So one that came through discussed the standardization of longitudinal natural history studies. And so the question was, is there any scoring system for assessing the quality of these studies that will allow for an easier apples-to-apples comparison and help to encourage standardization?
Oh, scoring system of, make sure I understand, are there scoring systems that assess the quality of natural history studies to create kind of a standard natural history study?
Yes, that's my understanding of it as well.
That I understand. Okay. That's a very good question. Not that I am aware of, not at the study level like that. There are assessments of studies generally, right, that we use to assess the quality of a study and the risk of bias. So that would probably be something that would offer guidance, looking at risk of bias assessments. And the way I've also seen other, that's probably the biggest, and then the other way I've seen folks start to kind of establish these newer and comparative groups are honestly through publication, and where they can be peer-reviewed and established that way, right? So just in the initial design and in the measures. I don't know if that makes sense.
It does. Great. Thank you so much.
Yeah.
And to, again, thank you so much for a wonderful presentation today. In interest of time, if you have any additional questions for Dr. Lamb, please feel free to put them in the Q&A box. She's able to stay on for a little bit to help answer any questions that come through. So we will try to answer as many questions that come through the Q&A box, whether live through a presentation or through the actual chat box itself. So thank you again. But I think we're going to move forward to Dr. Kemper at this time.
Got it. Thank you.
So Dr. Kemper is only speaking to us today about the evidence review process. There have been questions coming up in the Q&A chat box about various aspects that Dr. Kemper has acknowledged we are going to discuss today. So we're very excited for his presentation. And so Dr. Kemper, if you're ready to go.
I am ready to go. So first of all, Dylan and Annie and others who were involved with setting up this meeting, first of all, thank you for inviting me. I think that this is an incredible resource and a great opportunity for us. As I go through and talk about the evidence review process, one of the things I want you to keep in mind is that one of our goals is really to be transparent in terms of how the process works, and we want to work with you all to make sure that we really do the best job possible synthesizing the data. And we're also happy to talk to you about in general how the process works if you're considering having your condition nominated. So I'm more than happy to answer things as they appear in the Q&A, but more importantly, I'm easily accessible via email, and happy to talk with anyone, or if it's a question that I can't answer, to help get it to the right person. It clearly takes a large community to improve newborn health outcomes through screening, and it's just a real privilege to be able to work with you all. I'm going to hit some of the questions that have come up in the chat box, but before I get going, I just want to point out a couple of things that longitudinal data, like KK just talked about, really serves a few very important things. One is being able to track individuals over the lifespan helps us learn more about the condition and the best ways to treat it, but it also does a great job of helping us to make sure that individuals get the care that they ought to get. So there's really a lot of value in longitudinal data. And when I think about the evidence review process, beginning to collect data about individuals as early on as possible and carry it forward as long as possible helps us understand the life course trajectory. In the absence of screening, individuals can be identified with a condition through a variety of different ways and can enter into the system in different health states. And collecting data over the long term really helps us make sure that we're comparing the same things and gives us the best opportunity to identify whether or not there's a benefit of early intervention. So I just want to put another plug in about that. If you could go ahead and advance my slide. Oh, there I am, that's Sherlock Holmes looking at all this data. I have the standard disclaimer. Remember that anything that I talk about is coming from me and not from the Department of Health and Human Services, from the advisory committee. This is all me. Next slide, please. So it's important to remember, as you all well know, that newborn screening is one of the most successful public health programs, and it's really incumbent on us to keep it that way by carefully considering all the conditions that have been nominated for newborn screening. Next slide, please. So I always begin these talks by talking about the traditional criteria for what makes a screening test a good screening test. And I suspect that most of you on this webinar have heard this any number of times, but it really harkens back to Wilson and Youngner, who wrote a report for the World Health Organization back in the 1960s. And I'm distilling what that document does to a few key things. So first of all, the condition has to be an important health problem. So an important health problem could be something that affects a small number of people, but affects them severely, or maybe a larger group of people, but less severely. There's no simple metric for what's an important health problem. And I think that's important to keep in mind. Second of all, there has to be some understanding of the natural history of the condition, because if you're going to start modifying it by screening and early treatment, you have to have a sense of what impact that's having. There needs to be a latent or early symptomatic stage. So that means there has to be a time when the condition is not clinically obvious, because otherwise you don't need screening, right? That you would identify individuals other ways. I think there's an important nuance here for newborn screening, that sometimes a condition may be clinically apparent, but it's unrecognized because the healthcare providers or other people involved with the care of the infant may not be familiar with the condition or may not recognize it as such. So it's really, I think of it as either there needs to be a period of where the condition is less symptomatic, or has to be something that people would miss, that would just be easily unrecognized. There needs to be a screening test that can be feasibly done and that it's acceptable to the general population. There needs to be a treatment, and the treatment has to be more effective if started early. So if there's no benefit to starting things early, then there's no benefit for early detection. Somebody asked in the chat box if the treatment needs to be an FDA-approved treatment. when we do the evidence review, we are really looking at any intervention whatsoever, and not necessarily in FDA treatment. Another person asked about whether just having an FDA treatment is acceptable in and of itself. I think the key thing is that we need to understand something about the benefits of early intervention. And then finally, the last Wilson and Youngner criteria is whether or not the diagnosis and treatment are cost effective. Now, that's not something that we look at in the evidence review. We look at the overall cost of the screening test itself to get a sense of what the impact is on the newborn screening program. But our analysis is not based on reporting some, overall cost effectiveness metric. Next slide, please. The really important thing, and again, I think everyone on this call understands this, is that screening is really a process that begins with the screening test, but includes all this diagnostic and follow-up activities. And I can just tell you as a pediatrician, one of the places that people fall down on improving health through screening is just by considering it a one-time test and not considering all the other things that need to be put in place so that ultimately child health is improved. Next slide, please. So the Advisory Committee on Heritable Disorders in Newborns and Children, beyond being a mouthful, is the committee that advises the Secretary of Health and Human Services about the most appropriate application of newborn screening tests. It includes up to 15 members. These members are appointed by the Secretary, and it includes representation from other agencies within HHS. It uses a decision matrix as a guide when voting to put something on the recommended uniform screening panel or the RUSP. I'm going to talk about the decision matrix in a little bit. One of the key things, and this is confusing, is that the advisory committee makes recommendations to the Secretary of Health and Human Services regarding what conditions should be on the RUSP, but it's actually the Secretary that makes the final decision about whether or not to add a condition to the RUSP. And then from there, individual states can choose what things to include in newborn screening and the degree to which they're going to follow the RUSP. But ultimately, individual states make the decisions about which things to include. And I know, looking at the agenda for this series of meetings, that challenges related to the adoption of new screening tests is going to be covered by other folk. Next slide. So in terms of the evolution of the recommended uniform screening panel, the advisory committee has adopted an evidence-based approach, which I'm going to be talking about. And since adopting that, there have been 10 evidence reviews that have been completed. Some conditions have been added and some have not. The ones that have not are highlighted here: hemoglobin H disease, Krabbe disease, and neonatal hyperbilirubinemia. If you look at the reports themselves, it's easy to compare and contrast and understand why those decisions were made. And I can be more than happy to talk about that as I go through. Next example, next slide, please. So I just put this link on my slide, and I believe everyone's going to get a copy of my slides, just that you have a link to the nominating form. And again, remember that anybody can nominate a condition for newborn screening. Next slide. This is the decision matrix that the advisory committee uses. And yeah, I appreciate that it looks overwhelming when you first look at it. And I just wanted to take some time to tease it apart, because I think it'll help when you see the evidence reports, because we try to put it together to facilitate the decision making. So the key things that the advisory committee looks at first is the net benefit of newborn screening and how certain they are that that net benefit exists. So the way to think about net benefit is if you took all the benefits of screening for the condition and you subtracted all the harms. If you could somehow synthesize that in yourself. That gives you the net benefit. And net benefits could be significant, or they could be small to zero, or they could be negative. A negative net benefit would be where harms might outweigh the benefits. So you can go through that exercise, and you know, everybody's going to value things a little bit differently. And so this calculus of benefits minus harms is a complex one. But not only do you have to do that, you have to think about, well, how certain are you about your assessment? So you may think that the net benefit is high, that there's a significant net benefit, but maybe your certainty about it, maybe the evidence underlying it is not that great. And that's where you can see high and moderate levels of evidence. And you can see that plays out again on the bottom part of the slides, where you have small to zero and negative benefits. And then, you know, there's cases sometimes where the evidence is so low that you can't even get to the sense of whether or not there's a significant benefit or not. So again, if you put your perspective into what the advisory committee is doing, first they're looking at significant benefit and how much the, you're looking at net benefit and how much certainty there is around that. And that breaks you up into these different boxes. But separately than that, one of the two other characteristics that the advisory committee has to think about is whether or not the newborn screening test can be implemented in a safe and effective manner. And that gets to whether or not the newborn screening programs in general are ready and whether or not the screening test is feasible. So the primary recommendation from the advisory committee is based on the net benefit and the certainty. But in terms of issues of adoption and recommendations to the secretary about what newborn screening programs need, that's where the issues of readiness and feasibility come into things. Those letters that are in the boxes are just to help sort of easily communicate where people are feeling. But it's really, at the end of the day, how the advisory committee feels about the net benefit and the certainty about whether or not things get added to the RUSP. The other thing to know is that this decision matrix is not prescriptive about the ultimate recommendation to the secretary from the advisory committee. This is really a tool for discussion to make sure that everybody's communicating things in a clear and straightforward manner. But again, this is just an aid in the process of making a recommendation. And I believe that Dr. Powell is going to talk about that further. Next slide. So there are three major components of the condition reviews that we conduct to inform the advisory committee. Remember that the evidence review group itself does not make their recommendations. It's our job to synthesize what's out there. So we begin with a systematic evidence review. We looked at published and unpublished studies. We look at the second thing is we model potential outcomes. So we look at the evidence that we've been able to find from published and unpublished reports, and we imagine what would happen if you were to screen all nearly 4 million babies born in this country in terms of how many cases would screening pick up, how many false positives would there be, how does that compare to what might happen with usual clinical care. And then based on what we know about treatments, we can look at how that would impact health outcomes in a year or longer, depending upon what's out there. So that's the second thing we do. And then the third thing, and this is done in partnership with the Association of Public Health Laboratories, is we look at the ability of newborn screening programs to implement the screening for the condition. And that's where we look at the direct cost of screening as well. Next slide, please. So this is a framework that we use when we think about evidence review. And I'm just going to walk through it because I hope this is, I keep looking back about at the questions that are coming, and I think this will answer that. So First, we begin with where it says persons at risk. Well, that's the newborn population that we're going to consider for screening. We first look at, and we ask this question all the time, although we never find it, where you see that one up there that refers to our key question one. That's the overarching question. Is there high quality evidence that shows that adopting screening leads to health benefits in terms of decreasing morbidity and mortality? And the easiest way to get to that overarching question would be through something like a randomized trial of newborn screening. Well, we're never going to get a randomized trial of newborn screening. It's just impossible to pull that kind of thing off given the rarity of the conditions and the amount of time that it would take to follow children up. We're just not, we know that we're not going to see a randomized trial of screening. So in the absence of that, we march through what we call the indirect pathways. So first we look at screening. So how well does screening work at identifying the condition? And so you can see that screening going to early detection of the target condition. That really asks about the validity of the screening test and how reliable it is. Now there's going to be harms associated with that screening in terms of false positives. So we assess how many false positives there are, and we look at what's known about the harms related to those kinds of false positives. Then we march through and say, okay, what do we know about treatment for infants that would either be identified through newborn screening, or might be identified through newborn screening, the kind of, in the absence of children being identified through newborn screening, had to look and see what other kinds of studies are out there. But what do we know about the treatment early on into the condition? What do we know about the harms of that treatment? And how does that treatment modify what we call intermediate outcomes? So an intermediate outcome would be something that you can follow, but isn't necessarily a something that the patients or families can feel. So an example would be a blood test, some level of something that you can find in the blood, right? So in general, you can't feel those things. You can't feel an inflammatory marker, or you can't feel your white blood count, or you can't feel your level of a certain enzyme. But those are, there's these neurologic tests that KK talked earlier. You can't as an individual feel those things, but they're important markers. They're used in studies all the time. We look at what's known about the changes in these biomarkers, and then as we find studies like that, we look at what do we know about the association between changes in those biomarkers and changes in the health outcomes that people can feel. So quality of life, length of life, those sorts of things that are personally meaningful. Ultimately, at the end of the day, we want to know whether or not early detection through screening improves things that are meaningfully important to individuals and their families. And that's why we have to look at the association between these markers and things that are important to people. So we have to put together this whole chain of evidence to tell the story. Next slide, please. So what I can say about the evidence review process is we try to be rigorous in that we set standards for everything that we look at. We are ahead of time clear about our process. We are transparent. There's nothing that we do in secrecy, and we're more than happy to answer questions about it. And we talk to a lot of people to make sure that we're thinking about screening for the condition in the right way. We are holistic, as I said before in the little check box, that we really want to reflect the perspective of patients and families, the public health system, and clinicians that are out there, as well as researchers. I will tell you that as we develop our research plan for each condition that we review, we hold a series of technical expert panel calls. These are people who are knowledgeable about the condition. They include families, so that we really understand what it is that we're looking for. And those technical expert panels can be incredibly helpful in terms of pointing us to evidence that we might otherwise not be aware of. We appreciate that things are changing quickly, and we want to make sure that we're able to get all the information that's available. So somebody wrote in earlier about, you know, how we would consider treatment that's in development but not available. Well, you know, we can only include in the evidence reviews data that are out there about the effectiveness of the treatment, so that if it's something on the horizon but there's no data about it, we can't obviously use it. But it's not unusual for us to go to what we call the gray literature, so unpublished data, and try to synthesize that as best we can, because we appreciate that things are moving so quickly and we want to be as open to it as possible. Somebody else asked in terms of treatments if we would consider things like you know, supportive care or non-targeted pharmacologic therapy. We look for all that stuff, you know, including like, you know, other nutritional supports and that kind of thing. There hasn't been a case yet where non-targeted therapy has made the difference in terms of the kinds of health outcomes that we're looking for. But that's not to say that we don't look for it. Again, we try to look for everything that's out there and provide that to the advisory committee so that they really understand as best as possible about the benefits of early intervention. Next slide, please. So I talked before about the modeling. I wouldn't spend a lot of time talking about it here unless someone would like me to. The key thing about this is that we are limited in terms of the outcomes. This is when we you know, think about what might happen to the 4 million children born in this country each year in terms of their outcomes. So, I mean, it would be nice to be able to say, well, you know, 10 years later, 20 years later, if you were to screen, this is what might happen. Oftentimes, though, we're restricted. So if you looked at SMA, for example, newborn screening for SMA, we were only able to predict out about a year. This is challenging, right? Because some people say, well, how do you know what happens in a year? Maybe the therapy doesn't remain as effective as you might think, and they regress or something like that. Well, you know, that's beyond what we can say. Again, we really just stick to what's out there. But the longer we have data, the longer the more longitudinal data we have, the more convincing things can be for the policymakers that need to ultimately make the recommendations. Next slide, please. So again, I talked before about we try to inform the advisory committee about issues of readiness and feasibility for adopting newborn screening and costs and those kinds of things. And this is important when the advisory committee is making a recommendation so that they can set expectations for when things might come online. Next slide, please. So what I'll say is that in addition to the RUSP requires a high level of evidence. And remember that this is a public health program that could ultimately affect all newborns born in the country. And so there's the expectation, since it's largely done without consent, that we really know that there's a real benefit of this. But adding something to the RUSP is really just the first step in a complex process, ultimately leading to when newborns are tested for the condition. So again, it's important to keep, you know, even for conditions that are added, to keep working with your partners to make sure that things are done in a safe and effective manner for all newborns. Next slide, please. So I did this last year for those of you who were there in person, and I'll just say, and I know KK is nervous about this, but I promise I'm not going to sing. But courtesy of my other collaborators, John Paul, George, and Ringo. Next slide. So it requires a lot of work to get this together. So that's why I had my all together and come together now. There's a huge amount of work that goes on in the background to prepare nomination packages. And again, KK and I and the others on the evidence review group really depend upon the interactions with you all to make sure that we're appropriately considering the conditions. Next slide. And I would say that the process is rigorous and complex. So there we got the long and winding road, but there's a reason for it. You know, it's not to put up artificial barriers, but it's just to make sure that everything is in place so that so that ultimately we have the health outcomes that all of us want. Next slide. And I will end there with my last Beatles LP. You know, it's always hard to do this when you don't get any feedback. You don't know if anybody's smiling or about to get mad, but hopefully you're more smiling than not.
I can provide some feedback. Definitely more smiling than not.
Okay,
thank you so much for a wonderful presentation. There are definitely a whole bunch of questions within chat. I just want to pull a few out. In the interest of time, we'll keep it relatively short, but I do want to ask a couple of them. One of the more recent ones that came in that I thought was interesting that asked, how does the evidence review leverage FDA's work to link markers to outcomes in order to approve a treatment?
Yeah, so, you know, obviously the FDA process is a parallel train to what we do, and having FDA approval in and of itself doesn't tell you whether or not early intervention leads to better health outcomes. But because those pivotal trials, assuming that they make it to anything that we can get to, right? So the FDA, packages that are submitted to the FDA are not necessarily in the public domain, but assuming that we do have access to those kinds of things, then we do look very closely at the markers that are used there and the relationship between those and health outcomes. So, for example, the motor development tests that were used in the studies for SMA, you know, made our life a lot easier because those were there. So we do look a lot at that information, but it doesn't necessarily mean that we see everything because the FDA data are not necessarily in the public domain.
Great. One other quick question. Does the advisory committee consider data from international newborn screening pilot programs in the evidence review?
So I'm going to defer any question about how the advisory committee makes decisions to Dr. Powell in her role as the chair. I just want to be careful about that. But what I will tell you is that in the evidence review process, we do provide that information about screening in other countries. So, for example, in the past, we've information from Taiwan was very helpful in the Pompeii review. There was a lot of work that had been done in Europe around screening newborns for critical congenital heart disease. So we do synthesize those data. Now, the degree to which the advisory committee, how they weight that versus data from the United States is a question for Dr. Powell.
Perfect, and that is honestly a great segue because she is our next speaker. So Dr. Kemper, thank you again so much for your time. To those who have questions in the Q&A box who we haven't had a chance to get to, Dr. Kemper is going to do his best to answer a few of them.
Yeah, I'm going to go through and then email me, I think, and Dylan, you provided my email address, is that right?
Yes.
I am more than happy to do it. I feel like the lonely Maytag repairman if nobody's emailing me these kinds of questions.
Yes, we are going to provide Dr. Kemper's email. We'll put it in the chat box as well as it'll be in the follow-up email along with every speaker today. The email has given the okay to provide their email. So if you have any questions for any speaker, please do not hesitate to reach out to them. And that email will be provided in the follow-up email after today's session. So thank you again, Dr. Kemper, for your time and for your great presentation.
Thank you. Thank you.
That'll take us to Dr. Powell. Dr. Powell will talk to us today about understanding screening methods, and I will just transition directly to her. Dr. Powell, are you there and ready?
Thank you. Yes. Can you hear me okay?
Yes, we can.
Okay. So I was asked to talk about some of the screening methods related to newborn screening. Next slide. So as Dr. Kemper presented the Wilson and Younger criteria, I'll be focusing on the rapid and economical laboratory tests being available that we want to make sure is highly sensitive, so we don't want any false negatives, we don't want to miss any cases, and reasonably specific because we want as few false positive cases as possible. Next slide. So advances in newborn screening have often been driven by methodology, and I'll give you some examples of that. Next slide. So in the case of PKU, of course, it was back in 1934 that Dr. Furling first published the description of PKU as a cause of intellectual disability. And in 1954, Dr. Bickel described that the condition could be prevented or at least ameliorated by a diet low in phenylalanine. But then it took another almost 10 years after that before Dr. Robert Guthrie developed the bacterial inhibition assay for PKU, which was initially utilized by many states to screen for PKU, which was the first condition that was screened for in newborns. And it was in that same year that Massachusetts and Oregon began screening for PKU. Next slide. And then really the second condition that was screened for was congenital hypothyroidism. And states nowadays may measure the thyroid hormone level itself, T4, and or thyroid stimulating hormone, TSH. When that first started, a radioimmunoassay was utilized, which was, because it involved radioactive material, was challenging for labs, and it brought the need for sort of higher qualifications for screening laboratories to do that assay. Nowadays, immunofluorescent assay is utilized. Next slide. So I'm not going to go through all of the different conditions, but one thing that's been very important in terms of the ease of which newborn screening laboratories can add additional conditions is multiplex testing. So what I mean by that is that there's measurement of various biomarkers that are produced when an individual has the condition, and those can be measured either by enzyme measurement and or a fluorescence immunoassay. And nowadays there are machines that can do testing for all of the conditions listed there. So it makes it much faster, cheaper, and more straightforward to do testing when there is multiplex testing available. But that one machine is not able to screen for all conditions that are included on the RUSP and utilized in most state newborn screening labs. Next slide. So for the hemoglobinopathies, other testing methods are used, and they may include liquid chromatography, HPLC, capillary electrophoresis, or isoelectric focusing. So all those have been utilized for newborn screening for sickle cell and thalassemia. Next slide. Then, of course, the very large expansion of conditions that could be screened for in newborns came about when it was realized and discovered by Dr. David Millington at Duke that tandem mass spectrometry, which initially I believe was developed by the chemistry field, chemistry companies, but that it could be used to detect inborn errors of metabolism in newborns. And this, of course, allowed detection for dozens of conditions that then caused quite a large discrepancy between states, where some states were screening for 25 or 30 conditions, other states were still screening for only a handful of conditions, and that really led to the development of the RUSP. Next slide. Then when SCID was suggested as a potential condition to include in newborn screening, because it was realized that early identification of infants with severe combined immunodeficiency could lead to early death if they weren't identified early. And with an early stem cell transplant, of course, their lives would be saved. And a specific type of test called T-cell receptor excision circle, or TREC assay, was utilized and found to be very effective for finding children with low numbers of T cells, one of the white blood cells or leukocytes that our body produces. So the TREC assay is a DNA marker of normal T cell development. and it requires a quantitative PCR assay to test for that. Next slide. So then MPS 1 and Pompe disease, two of the many different forms of lysosomal storage disorders were added to the RUSP, as well as X-linked adrenoleukodystrophy, which is a peroxisomal disorder. And in order to detect these conditions, some labs are able to do that newborn screening through use of the tandem mass spectrometry. Sometimes they have to make slight modifications. Sometimes a second tandem mass spec machine is needed to do that. And then there's an alternative system called digital microfluidic fluorometry, or the DMF system, that some states are utilizing to screen for those conditions. Next slide. So we have, of course, the majority of conditions are screened utilizing the dried blood spot cards, which some people still refer to as the Guthrie cards, after Dr. Guthrie, who discovered the newborn screening assay for PKU. But then there are also on-site or bedside types of newborn screening that are done, and that includes the hearing test. Of course, very important that all newborns have their hearing tested prior to discharge from the hospital. That's done through two different types of methods, depending on which hospital you're talking about. So some hospitals utilize the otoacoustic emissions test, and others utilize the evoked response type of testing for that. And then if babies screen positive where there's a problem with that, they, as well as all the different conditions, utilize, have confirmatory testing. And then another type of on-site test that's done in all newborns is the pulse oximeter, as you see in the lower right, where the pulse ox machine is put on the baby's usually big toe in order to detect the level of oxygen. And this would be done in order to detect critical congenital heart disease. So certain types of severe congenital heart defects are associated with low oxygen levels. And utilizing all these different methods and considering all the different conditions that can be detected, approximately 1 in 150 infants will have a condition detected through one of these methods. Next slide. So I wanted to talk a bit about DNA-based screening. So that was started when newborn screening for cystic fibrosis started happening. And CF is caused by changes in the CFTR gene. Of course, it's an autosomal recessive condition where a child would have to have changes in both copies of their CFTR gene in order to have cystic fibrosis. Initially, most states utilized the immunoreactive trypsinogen assay to measure the level of that biomarker, IRT. But some states utilized a second IRT if the first one was abnormal, whereas others went to looking for common mutations in that cystic fibrosis gene. And that could be done through a PCR test looking at common mutations. Well, the problem with looking at common mutations is that common mutations are not always very helpful in certain populations. So in states such as California, where they have a great deal of ethnic diversity, it really wasn't very helpful to pick up patients who truly had cystic fibrosis. And so many states then started doing gene sequencing of the CFTR gene, but what's called next generation sequencing, which I'll talk about, was started and has become used in a number of labs. For some conditions, I talked about SCID before, there is a way to multiplex the test for SCID with testing for spinal muscular atrophy, the newest condition that was added to the RUSP. And then for some of the other conditions that are on the RUSP, sequencing is used as a second or third tier test for some conditions. Other labs are utilizing biomarkers and not doing sequencing. So for example, for MPS 1, where there are certain types of changes in the gene associated with MPS 1, where you know that that child is very likely to have a very severe form of the disease, versus some babies screen positive because they have what's called a pseudodeficiency copy of that gene, which would not be associated with any significant problems. So it is utilized as a second or third tier screen by some labs. Next slide. So what is sequencing? Well, when we talk about sequencing, it's really just reading the letters of the alphabet that make up the DNA sequence or gene. So if you look at the, on the left there, the C, G, A, and T are nucleotides. So you can think of our DNA is made up of letters limited to C, G, A, or T, which are nucleotides. And if there's a misspelling in the gene, that may or may not throw off how that gene functions. So how the product, the protein product made by that gene is made or not, or perhaps it's made abnormally. So that the initial type of sequencing that we did is called Sanger sequencing, after the doctor who invented it. And it's also sometimes referred to as first generation sequencing. Next slide. And then we have what's called next generation sequencing. And that is, similar in terms of you just need a sample of DNA, whether it comes from the blood, a dried blood spot, or some other samples such as a cheek swab, and then you prepare it, and then it's run through the sequencing machine, and then it goes through very sophisticated bioinformatics in order to determine what's a significant change in that gene and what isn't. Next slide. So the next generation sequencing, sometimes you'll see this term massively parallel sequencing used synonymously. It can search for variants in all of our genes, approximately 20,000 or so. That's referred to as a person's genome, their whole genetic makeup. When you see the term exome, that just means the exons, which are the coding parts of genes, and do the majority of work that genes do, but not all of it. That is only about 1% of the genome. But the analysis is very complex. So you can't just do sequencing and get a definite answer. You have to understand what's a significant mutation or what we call a pathogenic variant in the gene, and what's just a benign polymorphism. Because we know when we look at a person's total DNA sequence, there are many, many differences. There are many, misspellings that don't make any difference at all, and those are what are called benign polymorphisms. So this whole field is still quite challenging. Next slide. Certainly the cost of genomic sequencing has gone down greatly. If you think about the initial Human Genome Project, where it cost over $100 million, well over 100 million, and just to do the sequencing back in 2001, that was the estimated cost. Compared to Moore's Law, which accounts for, it's a computer term, looking at how rapidly our computer abilities improve. But compared to that, the cost of sequencing has greatly decreased. Now under $1,000 and estimated to continue to go down. So if we're thinking about utilizing exome or genome sequencing in newborn screening, it's still much too expensive to be able to do it on every infant. But the cost is coming down. Next slide. But theoretically, not accounting for the current costs, but really any disorder could be screened for if there's a known genetic etiology that's been established for that condition. Next slide. So could genomic sequencing, either with exome or genome, or probably more realistically a gene panel where there would just be a specific set of genes that sequencing would look at, such as those related to hearing loss, for example. When a baby is found to have hearing loss, we only know that their hearing is not normal. We don't know what the cause of that is. About 80% of congenital hearing loss is due to genetic conditions. About 80% of those are isolated conditions where just the hearing is affected, but about 20% are due to syndromes where there can be other problems such as vision loss over time. Also with the immunodeficiencies, with SCID testing, we know that a child is lacking their T cells, but we don't know what that is due to. Is it the SCID, is it the severe combined immunodeficiency form, or is it a milder type of immunodeficiency? And also, it may be possible to decrease the number of false positive rates when it's combined with biomarker screening. But I do want to point out that based on studies that have been done, funded by NIH, part of the NSIGHT projects that were done, we know that sequencing at this time at least will not replace biomarker screening. The biomarker screening is more accurate. And we just don't know, as I mentioned before, what is a significant change and what isn't. And we know that doing sequencing alone is going to miss children who have conditions with metabolic disorders. However, it will allow screening for conditions for which there is no biomarker, such as cancer predisposition conditions. There's a condition called multiple endocrine neoplasia type 1. In some forms of that, infants can have thyroid cancer that can occur within the first year or so of life. Usually by the time it's diagnosed, it's metastasized and the outcomes are not good. And then there's a form of colon cancer predisposition condition that can affect children called familial adenomatous polyposis, or FAP. And that can cause liver tumors as well as tumors in the colon. And then there are neurodegenerative disorders that don't have any measurable biomarkers. And a recent study has shown that early identification of that and early treatment can help ameliorate that very serious neurodegenerative disorder, Menkes disease. And then, is another example, cardiovascular disorders, conditions that can cause enlarged hearts that don't function well in children, disorders that cause cardiac conduction defects that could cause, sudden cardiac death, the connective tissue disorders such as Marfan syndrome that can cause enlarged aortas. So these don't have biomarkers. They can't be picked up through tandem mass spec, at least as far as we know. And so genomic sequencing would be a way to theoretically be able to screen for conditions like this. Next slide. So just to summarize, you can look at how the number of conditions screened for has increased exponentially since the first discovery of being able to screen for PKU, then rapidly increased after a tandem mass spec was utilized. And now theoretically, we could screen for many other conditions with massively parallel sequencing or next generation sequencing. And I think that's it. That's my last slide.
Great. Dr. Powell, thank you so much for a wonderful presentation. We do have one question in the Q&A box. It states, some states are considering the addition of SMA and ALD screening simultaneously. Is one of the reasons because both can be screened via DNA screening in order to maximize the state's resources?
I don't think so. I don't, I mean, to my knowledge, I'm not aware of the SMA and XALD. That may very well be, in development or being done some places. As far as I know, there was, utilizing the multiplexing with SCID assay and SMA. XALD, we were able to utilize, biomarker. We did a pilot study in North Carolina for that, and we're able to use the mass spec in order to test for XALD. So I'm not familiar with doing the XALD and SMA, but that may very well be.
Great, thank you so much. And
You're
thank you
welcome.
again for a wonderful presentation. So we are actually going to move through our break due to timing. So we're going to move straight into our panel. I want to remind everybody that today's session is being recorded, as well as we'll make all the materials available. So you have to step aside for a moment prior to the start of the panel. That is fine. But we are very excited for today's panel about how to launch and run a pilot study. At this point, I'm going to share my screen and turn this over to Annie Kennedy, who will be moderating this wonderful panel.
Hi, thank you, Dylan. Thank you everyone for joining us today. I'm really excited to be joined with really some phenomenal leaders in our newborn screening community who are really going to help us dive deeper into a nice follow-on to the presentations we've heard this morning. I know we heard this morning from Dr. Kemper that one of the primary questions that we have to answer through the systematic evidence review is, does newborn screening lead to better health outcomes compared to usual case detection? And when Dr. KK Lamb was providing her overview this morning around the key questions that are considered for the nomination package, one of those questions was really a beautiful segue into this panel today. And that question is, are there prospective pilot data about how well population-based screening works to find newborns within the condition? So what we're going to talk about here today, and we're joined by a panel that's really well positioned to help us understand this through a number of different lenses, is around how to design and implement pilot projects, who the partners are, who are needed to be a part of those collaborations, how each unique stakeholder plays into those pilots, and ultimately what pilots are designed to do for us as we are building newborn screening systems and programs. So I'm going to just introduce who is here with us today, and then I'm going to actually ask each of our panelists to provide an introduction of themselves with some context for the experience that they've each had within pilot programs and the role that they play within this ecosystem. So first, I'm Annie Kennedy with the Every Life Foundation, and am honored to be here today with you. My experience with pilots is that I've been engaged in the development of a pilot program for Duchenne muscular dystrophy, and full disclosure, have worked with a few people on this panel in developing that pilot program, and have learned from each of these women along the way. We're also joined by Dr. Amy Brower, who is the Associate Project Director at the Newborn Screening Translational Research Network at the American College of Medical Genetics, or ACMG. And then also we have Dr. Joan Kutzer, who's the former Vice President and Head of Global Strategic Services in Rare Diseases at Sanofi Genzyme. And then we have Dr. Michelle Kajana, who's the Director of the Newborn Screening Program in New York State at the Department of Health. So thank you to each of you for being here. I think for introductions, maybe if we could start with Dr. Brower.
Yeah, hi everybody. As Annie said, thank you so much for including me on this important panel. I'm Amy Brower. I'm the co-principal investigator of the NBSTRN. And so NBSTRN has been focused on supporting pilots, so both by creating resources and tools as well as working with the pilot site. So we've been involved in the SCID pilot and now a Duchenne pilot, as well as tracking the outcomes of the IDIQ task order pilots supported by NICHD. So these are pilots that are pretty focused, 2-year pilots, about 80,000 newborns on conditions that have been recently added to the RUSP. So, so thinking about, what do we do for long-term follow-up, both before and after something gets on the RUSP? I wanted to, use my introduction to say they're really different data sets. So as we begin to treat population-based identified kids early and intervene early, often the clinical course is different than what we see in a natural history study. So really thinking about how do we build those longitudinal data sets, we have to think about whether it's before or after the RUSP. And hopefully we can talk a little bit more about that during the question and answer session.
Great, thanks so much, Amy. Next, maybe Joan, could you provide an introduction? Context. Oh, you're on mute. Can you unmute yourself?
Sorry. I'm Joan Coitzer. I retired last year after spending 24 years at Genzyme, which eventually became Sanofi Genzyme. In that time, I was part of the drug development teams for several of the lysosomal storage disorders, but I also ran our efforts on newborn screening and improving diagnostics. Specifically, I had the pleasure of being trusted by the whole genetics and newborn screening community to really coordinate all of Genzyme's efforts. And there's really 4 things relevant to the discussion today. One is that I ran the research lab that optimized and transferred the methods that were developed by Michael Gelb and Dr. Chamoles. I oversaw the production of the ASRs so that labs could perform newborn screening for these LSDs and the coordination of the CDC distributing them for free. I was involved in the pilot programs in Taiwan and Washington State, and I was part of the teams that nominated both Pompe and MPS1 for newborn screening on the RUSP. Thank you.
That's phenomenal. We'll dig into all of that in just a moment. Thanks. And then Michelle, could you provide an introduction?
Hi, I'm Michelle Kajana. I'm the director of the newborn screening program in New York. Thanks Annie and Dylan and Everlight for inviting us to participate in this panel today. I have been involved in several pilot studies, and you heard Dr. Kemper earlier talking about the evidence review and the technical expert review panel. So we had funding for SMA pilot studies. We were able to actually find a case that we used to add evidence that newborn screening can detect a child, and that the child was entered into, at that point, a clinical trial, but shortly after that, an FDA-approved therapy. So we participate a lot with Alex's group with evidence review. We're also, as Annie mentioned, we're running the Duchenne pilot study right now, and that's ongoing for approximately 1 more year. And we also are involved in NIH-funded pilots as the testing lab for Dr. Melissa Wasserstein's LSD pilot that was ran from about 2012 to 2017, and now we are just poised to launch a pilot with her and her colleagues at Montefiore to do a panel of 13 lysosomal storage and other conditions. A lot of them are conditions that have clinical trials, have treatments, and are poised perhaps in the near future or the future to be added to the RUSP. And in doing all of this work, we work with Amy and her staff at the Université to make sure we have that follow-up data that is necessary for the RUSP nomination and have that data available for review by the committee. So thank you.
So super, thank you guys. So I think I want to start at the beginning a little bit, because I think we have there are a lot of people from a lot of different stakeholder groups participating today. And I would imagine that a number of the people who are participating are probably early stage and are just beginning to think about creating a pilot or building a protocol around a pilot. So maybe we could spend a few minutes talking about that through each of your respective lenses. Amy, I'd like to start with you. One of the things we heard a lot about this morning was the importance of the longitudinal data collection. And you and your group are really uniquely positioned to really help facilitate that. So maybe if you could spend just a couple minutes talking about what NBSTRN does as far as longitudinal data collection is. I know we speak in acronyms in this world, but I know the LPDR is something that some people may or may not be familiar with. And then also, maybe as you talk about that, what that process for developing outcomes with respect to individual, some of us think of that in terms of regulatory grade outcomes, but how is that different in newborn screening if people are starting to think about developing a pilot?
Yeah, thanks, Annie, for that question. You know, Dr. Lamb gave us a really nice overview of what the meaning of longitudinal studies is this morning. And some people ask questions about the evidence base and how do you sort of rank longitudinal studies. And we all know that, you know, a randomized control trial is, you know, sort of the top of the evidence review pyramid if you had to draw it. But in rare disease and newborn screening especially, these longitudinal studies are really important. So one of the key deliverables for the NBSTRN is to really enable that longitudinal data collection. So when we think about the diseases that are part of the RUSP or candidates for nationwide screening, we really look at the clinical course of the disease or the condition. The clinical course really helps us determine what kinds of questions would be important to collect over time. Again, you really need to think about the hallmark characteristics of a condition and what's the clinical consequence of having that condition. So when we began years ago, almost 12 years ago, we started with the inborn errors of metabolism and brought together specialists who treat those individuals, not only the clinical specialists, but individuals from schools, from, you know, all the different members that would touch this newborn throughout their lifespan, because most of the conditions that are part of newborn screening require lifelong care. So we really wanted to extend it across all these different really professional and teams that support this individual throughout their lifespan. So using a few examples, so thinking about severe combined immune deficiency, obviously it's in its name, the real consequence is immune deficiency. With PKU, the consequence is irreversible brain damage and intellectual disability. But we really have to extend the longitudinal data set beyond that clinical characteristic to really think about comorbidities. So things like seizures, tremors, behavioral, emotional, and social problems with PKU throughout the lifespan, and with SCID, things like pneumonia and chronic diarrhea. We also have to think about the consequences of early intervention and treatment. So a disease before newborn screening is different than a disease after newborn screening, because your access to care matters, your type of treatment matters, how soon you get the treatment matters. So we really need to broaden that definition in a longitudinal study after something's part of a nationwide screening to really begin to capture and learn about this new natural history of this condition now that we're intervening. So some things that I've seen lately that we're beginning to add to our data sets are things like capturing information on graft versus host disease for free survival. So not only quality of life assessments, but really things that impact. So we're trying to intervene early. We're trying to treat the disease or cure the disease. And then we need to follow these kids over time to really see how we did. So we need to include parent surveys, patient surveys, clinicians, schools, you know, other team members in those kinds of efforts. And I want to plug the National Library of Medicine. They have a CDE repository, which is a common data element, sets of questions and answers that we can all refer to. They look at things like patient-centered outcomes. They have a patient-reported outcomes measurement system, as well as the NBSTRN set of questions and answers. So I'll put that link in the chat window so you can all check that out if you're starting to build these data sets. We're working with Melissa Wasserstein's team to really think about, for these new candidate conditions, what questions should we ask? And so we're really here to help. So if there's any groups on the line that are beginning to put together pilots or even starting to think about these natural history studies, feel free to reach out to us and we can bring together groups of experts to help design those types of longitudinal data sets.
That's great, Amy, thank you. And we'll make sure that that information about how to contact you is readily available to participants. Joan, I think I'd like to move to you next. I think so one of the things we focused on last week at the boot camp was the importance of collaboration. And I think from the talks this morning and this panel, I think it's really evident and how critical all of the stakeholders in the newborn screening space are, and that the role of collaboration just cannot be underscored enough. When you were giving your introduction, you really gave some really, your role as a member of industry was clearly critical in the pilots and in the programs that you worked in. And so what we're beginning to see in our space is an increased interest in the newborn screening space on the part of our industry partners. And I would really love to hear from you and your perspective on what are the different ways that industry can really lean into this newborn screening space and participation, whether it's just in pilots or the building of the newborn screening systems as we're moving them forward. Just any thoughts that you have around that from your lens.
Okay. So first, I think that industry is an important partner here. I think that some people tend to think of industry as only funding things, but in a way, in genetic diseases, industry has to be part of it also as experts. So let me give you an example. So certainly we funded most of the work to get Pompe and MPS newborn screening going. But we also realized that the physicians that treat babies with these genetic disorders, they see babies with the 6,000 different monogenetic diseases. And inside at Genzyme, we had disease experts. We had experts in knowing how to treat the children and what the signs and symptoms were. We had experts in diagnosis. And so we lent that expertise in designing the different pilot programs. And then, I don't remember if Michelle was there, but before New York started Pompe disease newborn screening, a group of clinicians got together. They got all of the physicians who would get referred these babies to get a confirmed diagnosis of Pompe disease. And our medical affairs team and Dr. Priya Kishanani from Duke had an evening of describing to those physicians what Pompe disease was, what to expect, and answered any questions on the treatments too. I also think that there's a key role and responsibility of the industry, not just to promote newborn screening, but to demonstrate the benefit and the value of earlier treatment. We certainly did that in the context of Pompe disease, where we set up the pilot in Taiwan so that every baby who got diagnosed as a result of that newborn screening pilot was offered treatment immediately upon a confirmed diagnosis, and then were monitored using the exact same protocol that we used in our pivotal clinical trial so that you could compare the data directly. And then finally, this might sound like a plug for Alex, and it looks like he left, but we have disease registries, and those disease registries are international registries where we collect outcomes data. And most of the disease registries that the therapeutics companies have are a regulatory requirement. But Alex contacted us when they were doing the Pompe disease evidence review, and he asked us to pull survival data and some functionality data for the kids of children diagnosed and treated before 3 months of age and children diagnosed and treated after 3 months of age. And so that's really another way that industry can collaborate, and that is doing custom output to answer the questions that are so relevant to newborn screening.
That I feel like we should take that answer and make it a tip sheet somewhere. That was really a wonderful mapping out of a significant role that a member of our ecosystem could play. That was really great. Thank you. Michelle, I know there are a lot of people listening today who are considering or building pilots or considering working in the pilot space. I know that when we were navigating our pilot, we really we're grateful to you for some of the guidance that you provided to us. And I also know that our public health labs right now are really the unsung heroes in this space today because of COVID and newborn screening and everything that's coming at you. So I would just love to hear from you that as you are considering the pilot opportunities and the partnerships that are in front of you, what are some key considerations that we as groups that are working to develop protocols and working to plan pilots should be making? What are some of the factors as far as timelines that you take into consideration, readiness for a pilot? What can we be doing to have as complete a dossier or a proposal as possible, if you will, before we start to come to a state health laboratory and look to partner? How do we start those conversations? What makes for a good partner through your lens? And how do we facilitate that? From what is your preferred way to begin to engage with partners? So that was a lot of questions all wrapped into one.
Yeah, so I guess one of the first things that, when a group reaches out to a program in order to try at least the beginning discussions about a pilot study, we want to first define what the pilot actually is. And you'll laugh because this is my mantra. There's different kinds of pilots, and so we need to be clear in what the end game is going to be. Is it the RUSP nomination? Is it a feasibility study? Is it a validation type study, just to look at whether or not it's even possible to do a consented pilot? Consented pilots are expensive. They come with a lot of rules and a lot of things that you need to consider. And so I think one of the most important things up front is to figure out what exactly you want to accomplish in the pilot, and also engage stakeholders early. As a newborn screening program, we have many moving parts as well, and we really need to involve all of those moving parts and then work with the organization who's interested in doing the pilot, and then have a lot of the long-term follow-up pieces sort of laid out. As Amy mentioned, our first one was SCID, and we did a lot of planning for that, and that was 10 years ago. Pretty much this week we started doing that pilot, and so we had a lot of conversations about what we would want to accomplish, and one of those goals was to screen as many infants as possible and to be able to report those. So from a newborn perspective, you have sort of the lab piece, which is maybe the test development. If you're working with a vendor, they may have a product that you can use for the test, or do you need to develop an assay? So you have sort of that lab circle. And there's a famous Venn diagram that people use to show all of the overlap of the various parts. You also have to include the follow-up group, because when the laboratory produces a result, your follow-up staff have to be knowledgeable and trained onto how to make that referral out, so that the correct providers understand that this is a screen positive result. And so you need to sort of educate your follow-up staff. Another thing to consider is your LIMS system, your laboratory information management system, and how you track samples that come in with a consent if you're doing a consented pilot study. You need to determine with your group, are you going to report this as something separate, or are you going to report it as part of the newborn screen up front? Because you have to configure your IT to make sure that the timing of the testing, the follow-up, and everything kind of comes together with the newborn screening report. Or are you going to pen this and report it separately? So that sounds kind of like a simple consideration, but it actually can be pretty complicated. Sometimes the state also, from a program perspective, might have to get higher level approval to even be able to conduct that test. So that's an important question to find out. Is it something that the state administration will even allow you to do? Again, vendor engagement. And with our Duchenne project, we had vendor engagement from very early on, because we were planning on using a product that was being developed for the testing. In addition, we worked with the typical consent model. You need hospital staff, sort of boots on the ground, to consent families in real time. And so those staff have to be involved. Everyone has to kind of understand the protocol of that. They all have to come in with the same message. So the hospital staff in the nursery that are working on a project have to be on board. One of the most effective things is to, from a lab perspective, is to appoint a lead that will communicate with the stakeholders and with the organization. Having a point person, there's, like I said, a lot of moving parts. We have institutional review board approvals. We have subcontracts to work out. We want to make sure we keep our providers informed, the organization informed. And so if there's leads at each of these places, then we can all communicate and make sure everyone stays on the same page. Obviously, you need to engage your specialists in that field and get their buy-in that this is something they think is worthwhile to put in the newborn screening space as well. There's a lot of conditions out there that may have a test that can be performed, but again, this long-term follow-up piece and the registry piece of whether or not an early diagnosis will be helpful, and do your specialists actually buy into this? From a lab perspective, we certainly can maybe do a test, but you need that downstream buy-in as well. Another thing that we found is important is to let pediatricians in the field who are ultimately seeing kids for all of their other health care know that this pilot is going on, so that when they get a report, they understand, you know, that this pilot is actually happening. And that's done either through an email blast, it's done through putting information in each of the reports, and there's different ways to accomplish that. But that was one of the sort of challenges that we worked through with the Duchenne study. And identify your goals and metrics early and define what the deliverables are in the protocol, and be sure that everyone is on board and that all the interests are accounted for. So kind of a long answer, but there's a lot of moving parts.
There are a lot of moving parts. I guess a question for all of you, and you know, and anyone who wants to tackle it first can, but I think what is the difference, or to what degree should a pilot be designed and geared toward developing evidence to support a nomination to the RUSP versus geared toward the next step beyond the RUSP, right? Being the setup as a demo, if you will, for state implementation, readiness for nationwide implementation. And is it the same thing? Is it different? Once there's a RUSP nomination, is there a pivot that occurs? So can you talk a little bit about that?
I'll jump in first just because I think MBSTRN's role is really on the research side. So Annie, it depends on how mature the screening technology is, or the treatment, or how much we understand about the disease. So if we're pretty far along and we can kind of check some of those boxes, and we're just, you know, really doing what New York State does so well, is implemented technology in a high throughput setting, because babies are born every day, as you've all taught me, you know, really making that transition. I loved how you used the word pivot, because there really is a pivot, and we think of it as sort of translating, you know, research findings into public health and clinical care. So in designing a pilot on the research side, there are some different considerations. You know, you're trying to find out some of the same things like analytical and clinical validity of a screening test, whereas in a public health setting, after RUSP, you're really trying to make sure it works within your lab and works for the number of babies you get every day, the number of samples you get, you know, how your whole network is set up. And I'll let Dr. Kajana address that. But I do think they're different. I think that the research pilot has a lot of basic things to sort of prove when you prove that a screening and diagnostic technologies work, as well as understanding more about the interventions and the treatments. And I wanted to say that I really think the involvement of parents and parent-based registries are so important, because we're finding with the Duchenne pilot that to get the long-term follow-up data, we really can use those registries as surrogates for newborn screening, because often in genetics, we see family history. So we see the second and third child born, and knowing about them either before or shortly after birth, so that can mimic a newborn screen identified newborn as far as generating that long-term follow-up and outcome data.
That's great.
I agree. From our perspective, a lot of times you will see you know, NIH funded or a report in the literature where there is a test for a specific condition, and you know, a newborn screening program may look at that and want to determine whether or not it could be implemented in a high throughput setting. So in order to do that sort of a pilot study, you really do have to have all those pieces that I alluded to, and the end game that Amy talked about with the follow-up. For a RUSP nomination, you need all of those pieces to be taken care of and accounted for in the nomination. If it moves to evidence review and then gets voted and approved by HHS, then you move to the states, and that's where Joan comes in, and vendors and industry, because as she mentioned, she made available reagents that people could use for the lysosomal diseases testing, which allowed more states to implement because they had availability of reagents. You have to make sure when you want to do something nationwide that there is enough material out there for distribution so that states actually can implement, and so that their providers also understand what the follow-up protocol will be. There's many states that have very few geneticists or very few specialists, and so everyone has to be brought up to speed on how these babies' care and diagnosis and evaluation will be handled.
So from my point of view, our goal was to determine if newborn screening for Pompe disease improved outcomes, and if that was true, nominate it for the RUSP. So I used that RUSP nomination form as my to-do list and made sure, because I figured that that advisory committee had the smartest geneticists and public health people in the United States make that form, and we used that as our roadmap. And it was enormously useful as a roadmap. And the other thing I want to say is, I think Michelle and Amy touched on it, is that when we did the pilots, we had very specific goals and they were laid out ahead of time. Everybody agreed on it, and then we made sure that all the stakeholders were involved in that pilot to make sure that that pilot was successful and that we were judicious about the nomination form.
That's great. This is all great guidance. I want to remind people we're going to be posting this talk because I feel like anyone who's thinking about a pilot, or even if you're in the middle of a pilot, as I am, you need to hear this, listen to it a couple times because there are opportunities to refine your pilot. I think Joan's point about using that nomination as a guide is really critically important and can't, again, be stated enough. I think I'd like to end with giving you each an opportunity, if there's if everybody had one takeaway from the most important thing to think about when you're thinking about a pilot, or your biggest aha in working with pilots. There's just something you wanted everyone to leave here today with something, what that would be from your perspective. I'll give you a second to think about that. I was just looking through the Q&A box. There are a number of comments and questions in the Q&A box about collaborations and ways to work together as rare disease communities to ensure that we're collaborating either through collaborative funding models for pilots, which we're beginning to see some of those, which have been really tremendous, or there's a few people have mentioned Dr. Wasserstein is leading a model in New York that has a number of different conditions that are operating together. And so I think throughout this boot camp, there will be opportunities to learn more about those. And then we have some breakout discussions, which if there's enough interest in that topic, Dylan, I'm saying this so Dylan can hear, perhaps we could dedicate one of those breakout discussions to that topic in some way, so we could actually spend time on that and not spend just 30 seconds or a minute on it, because I think those are really important topics, and especially in rare disease, we are going to have to look at where the synergies are in the conditions that we're working on and who the partners are that can come together around those conditions. But with that, I would like to ask each of our panelists what their parting thought was, or their most important thing that they'd want people to take away from today might be.
I'll get started, Annie. So what I think is really important for all of us to think about, and I'd love to hear everybody's thoughts, is really how do we identify those handoffs? So we have a research pilot, we've got a state-based pilot when they're going to implement. There's so much learning that happens at each stage, whether it's from a clinician or a laboratorian or a school teacher. How do we make sure that that knowledge is translated from one partner to another outside of peer-reviewed publications? That's always the gold standard, but not all of us have time to sit down and write a paper. So how do we, generate that shared knowledge? And I would also say collaboration is key, whether it's industry, NIH funding, HRSA funded, state labs, parents, all of these partners working together. And that's why I think Every Life, bringing all of us together from all different walks of life, is so valuable.
Great, thanks, Amy. Joan?
So I think the most important thing is to have very clear goals for pilot programs. So we were involved in 2 pilot programs. I told you the goal for the Taiwan pilot program was to see if newborn screening improved outcomes, and it did. Our goal for the Washington State pilot was to answer the criticism is a strong word, but what the advisory committee said about the first nomination for Pompe disease. They said you need a multiplex assay, and we want you to determine the false positive rate with that assay. So we had very different goals, very different stakeholders, but we made sure that all the stakeholders were present from the beginning of the planning process.
That's terrific. Thank you. Michelle?
So goal-oriented was my first one. My second one is for programs also to remain flexible with shifting timelines. Things often take a lot longer, and make sure that that is built in so that everyone understands and isn't disappointed on how quickly things may or may not move, giving a condition and also where a program is and its ability to actually set up a pilot. So if you already have the Melissa Wasserstein type model where you can slot in a new condition, which that program is built to do, that will be a different timeline than approaching a state who's just starting out and trying to figure out how to get all of the boots on the ground, get them educated, and actually get that first specimen in for testing. So I think the 2 important things are understanding timelines and flexibility.
That's super. Well, I would like to thank each of you for being a part of this panel today, but more, I would just like to thank you for those who are new to the ecosystem of newborn screening. A lot of different programs and conditions have been discussed today, and those conditions have successfully been moved to RUSP nomination and state implementation, largely because of the leadership of these women and the teams that they've led and the collaborations that they've worked on. So I think we, just on behalf of the communities that have benefited from your work and your expertise, and you generously then sharing that with other communities who now are coming behind, I just want to say thank you. So thanks for your time today and then all that you've done. So thank you. All right, Dylan, back to you.
Great. Thank you guys so much for such a wonderful panel. And thank you everybody today for their time and for another wonderful boot camp. Again, I want to thank our sponsors for supporting this. And thank you again for being here. We're looking forward to next week. Next week, we're going to dive a little bit deeper into the advisory committee as a whole, kind of the review process, what exactly that is like, the challenges they typically face, hurdles they typically see, as well as what we're very excited for, which is a kind of one-on-one chat between Dr. Cynthia Powell and Dr. Joseph Bocchini, the current and most recent chair of the advisory committee. So we're very excited for next week. So we encourage everybody to return next week. In addition, the materials from today will be made available as well as a recording. So thank you again. And please do be on the lookout for the follow-up email, which will include the emails for today's speakers if you have any additional questions. So thank you so much and hope everybody has a great day.